For something to be continuous at a point, the limit as x approaches whatever that point is, we'll just call it a, as x approaches 2, as x approaches 3, the limit of the function has to be equal to the actual value of the function, okay, at x equals a. So like if we want to know if it was continuous at x equals 2, then the limit as x approaches 2 of f of x, whatever that y value is, it should be the same thing as if you plug in 2 into the function. So we got a piecewise function. Let's go through the options. We're supposed to determine which of the following are true. They say f of x is not continuous at x equals 3, and that's a big question point because it switches behavior at x equals 3. Because it's not defined at x equals 3. Actually, that's not true right off the bat. It is defined at x equals 3. They say greater than or equal, less than or equal to 3. So it is defined at x equals 3. We have a value there. F of 3 exists. That's true. You can plug in a value for 3, and it's square root of 6 because we use this function. But f(x) is not continuous at x equals 3 because the limit does not exist. No, that's not true either. Look, if you take the limit as x approaches 3, actually, hold on, because for the limit to exist, the left and right hand limit would have to be the same. So for the limit to exist, the limit as x approaches 3 from the left needs to be the same as the limit as x approaches 3 from the right. If they're not the same, then the limit does not exist, and this would be the correct answer. So if you approach 3 from the left, that means you're slightly less than 3. So that means we get square root of 6 if we were to just substitute 3 into that top function. And if you approach 3 from the right, that means we can just plug in 3 but into the function that's a little bit greater than 3. So if you do that, 3 squared makes 9, 9 plus 15 makes 24, 24 minus 24 makes 0. Oh, this is square root of 6. So that's not true. The limit does exist. The limit from the left and the limit from the right are the same. So the limit does exist. That's not true. F of 3 and the limit as x approaches 3 of fx both exist. Now we determined this is true. F of 3 does exist. You just have to plug 3 in here. The limit as x approaches 3 of fx exists. But it says, but f of x is not continuous because the limit does not equal the exact value. Look, if you plug in 3 into this function, you get square root of 6. That's the same thing as the limit. So this is not true. That should say equals. So it is continuous. It met all those properties. The limit was the same as if you plugged in x equals 3. So we got another piecewise function here. We're supposed to determine which of the following are true. Is it continuous at x equals 1? So again, here I'm just going to use shorthand, L and right for left hand and right hand limits. The left hand limit at x equals 1, we determine that with this function. And you can just plug in 1 in there. So that gives us negative 3. And the right hand limit is determined by this function. If you plug in 1, 1 squared is 1. 1 plus 2 makes 3. 3 minus 6 makes negative 3. So the left and right limits agree. Is it defined at x equals 1? It is, because it says greater than, this, again, I messed that up. This is x is less than or equal to 1. If it said this, then we'd choose this option, because it's not defined anywhere at exactly 1, okay? But we're dealing with this. It says less than or equal to, so it's not true. It is defined at x equals 1. Fx is not continuous at x equals 1 because the limit doesn't exist. We just found out the limit does exist because the limits agree. It's not continuous at x equals 1. No, this is also not true because if you were to plug in 1, that's just going to be the same as the right-hand limit. No, sorry, that's going to be the same as the left-hand limit this time, but they'll give us the same value. If you plug in 1, 1 minus 4 makes negative 3. So that's not true. It's continuous.